And this is the final section in this unit. This is about a new technique called back titration, which involves one more steps before we do the titration. Let me introduce. So far what we have learned is something called direct titration. In case we want to find the number of mole of HCl or its molality, well, easy. Just let it titrate against a standard sodium hydroxide is okay. But sometimes it is very difficult for us to carry out direct titration. In such case, we need to do something more. We call it indirect titration. So the situation may be the sample is too volatile. For example, for ammonia solution, because the ammonia gas will keep escaping, so we can expect the molality is keep on decreasing. The titration should be carried out as fast as possible to minimize the amount of NH3 escaped, or the reaction rate is too slow. For example, we want to find the amount of calcium carbonate in the eggshell, but eggshell is not a solution. We cannot use eggshell powder to carry titration directly. So what should we do? First, we need to react our sample with assessed but known amount of chemical A. Next, we need to find because chemical A is in assessed, right? And known amount. So after they react with our sample, there should be some chemical A remains. And in the second step, we carry out titration by chemical B to find the unreacted chemical A amount. We use this example as illustration. We want to find the amount of ammonia solution in the sample. First, we react ammonia gas with assessed HCl. This is easy because the neutralization, it takes almost no time to complete, and all the ammonia will gone and a few HCl is left because they are in assess. The second round is we try to titrate the resulting solution with sodium hydroxide, and of course we can find out the amount of unreacted HCl through titration. And this is a good picture for you to illustrate. You can see first the NH3 will react with HCl. Of course, we have no idea how much NH3 we got, but we're sure how many HCl we have input. Next step is we add the sodium hydroxide through titration. Because the sodium hydroxide solution is standard, we can get the number of mole of sodium hydroxide used and get the amount of HCl remains. Finally, the amount of NH3 can be found by subtraction like this. So let's see how the questions looks like. There is marble and added to hydrochloric acid. A titration is carried out. So you are required to find the percentage by mass of calcium carbonate. Calcium carbonate, sodium hydroxide on one side. On the other side, we have HCl, and it is 80 cm cube, 1.2 m. So you can find out which one is in assess, right? We need to write down the step title clearly. The first is we find the number of mole of sodium hydroxide and HCl, right? Because both volume and molality are provided, and amount of HCl, and here shows with the number added here. We can find the amount of HCl used to react with calcium carbonate. I think this is easy for you to understand. Next, we need to write down the chemical equations between the calcium carbonate and HCl. Again, from the mole ratio, we can find out the number of mole of calcium carbonate, and hence its mass, number of mole times molar mass, 1.9 something gram. So finally, we need to find the percentage by mass of calcium carbonate is 96.1. So you can see it is easy for you to understand in case you draw such a pictures for you to understanding. And here we go further to study one more questions. Here we have an anti-acid. So you can see I try to use different color to illustrate different chemicals, and again draw the pictures or diagram for us to understanding. This is magnesium hydroxide, and this is used to against nitric acid in a cell, and the sodium hydroxide is used to react with the acetic acid. So you can see that's why this is important. At the starting point, we try to find the number of mole of these two substances, right? So you can see the amount of nitric acid react with magnesium hydroxide will be the subtraction between these two number of mole. But first, we need to write down the chemical equation, and mole ratio, we write the step faster, so we try to skip some of the steps. Number of mole of magnesium hydroxide will be first. This is the amount of nitric acid react with magnesium hydroxide, amount of acid. But don't forget the mole ratio. That's why we need to divide it by 2. Should be this way. And next, we need to find the mass. Again, number of mole times molar mass is 1.1 gram. Then the percentage by mass, mg/2 will be mass over the mass of the tablet is 1.2 gram times 100% is 94 something percent. Now, you should be careful. The 1.2 gram is the mass of the tablet, and this is not a pure magnesium hydroxide. Well, otherwise, we don't need to calculate the percentage by mass, right? So please have a look on these questions. You can see with the diagram here, the problem become easier for you. So in next video, we're going to discuss the questions mentioned in the exercise set.